Sagarni Tota, studying in Kaitanins in the stream of Electronics and Communication Engineering. And we designed a project that is named as a low power based Mac architecture using DSP application. And these two are the my team members. And the total aim of our project, it reduces the power consumption and time delay using the 4:2 compressor is applied and it compresses and reduces the partial product. This product reduces the maximum output. The extract, we propose a high speed and energy efficient 2-cycle Mac architecture that supports the whole numbers. The efficient Mac architecture uses the 4:2 compressor and it is applied in this concept. And the low power high speed 4:2 compressor is used for fast digital integrated applications, and the Mac consists of the multiplier and accumulator unit, and the 4:2 compressor has been widely compressed the multiplication utilization, and when the multiplier uses the new partial product because the multiplier decreases the partial product and ultimately it will be decreases the maximum output delay. And when we go to the introduction for the project, we are using a DSP application. It is nothing but a digital signal processing. It is usually involves the multiplication and accumulation. The Mac unit is nothing but an integrated multiplier. It have a adder unit also, and this Mac is a major digital block used extensively in all microprocessor and digital signal processing applications. And for example of the Mac unit is orthogonal frequency division algorithms. In this frequency division algorithms, we are recently used the Mac unit also. One of the example is that. And next, the compressor is initially utilized in the phase of a partial product because it will be increases the speed of the multiplication because of the compressor. We are using the 4:2 compressor. So because of that compressor it will be increases the multiplication operation speed and it will be ultimately decreases the maximum output delay. And in last few years onwards, the main consideration of the Mac unit is to design the low power consumption devices, and the main goal of our project is using the VLSI to implement the pipeliner Mac architecture for the high-speed DSP applications. And why we are using this Mac means various architectures are involved in the multiplier and adder units. So because of that, we are using the Mac. And the total coding process will be going in the VHDL. VHDL we are using for to describe the hardware units, and the overview of the Mac architecture is it will be the basic arithmetic operations will be done in the Mac, so it will be decreases the power delay and it will be consumes the low power. So that way we are taken Mac architecture, and the existing and proposed architecture we are going to explain now, Srivash.
Okay, coming to our project, our existing method is we use full adder. In full adder, you will take two inputs and the output is one sum, and the other operations are done with some carry. In existing compressor, structure helps in lower power consumption, and the existing compressor architecture enables a new features like specific constant, specific characteristics. Some of the characteristics like some arithmetic operations are done. In coming to our proposed architecture, the minimum interconnection in some parts reduces. We use in this device reduces power consumption with minimum interconnections and independent carry logic to reduce horizontal carry failures. And in existing architecture, the compressor architecture built using lesser fan-in gates. We use lesser fan-in gates to reduce the input operations and carries to reduce the power consumption and increasing the carries. Logic implementation with lesser fan-in gates leads to much of interconnections with the significant impact of the glitch switch power and delay. And if we come to our proposed method, in existing method we use a full adder to the device. But if we use the full adder device, you can make a big process. That's why we use in MAC architecture and DSP applications. Most of the DSP applications require computation of the sum of products of a series of successive multiplications. In order to implement such functions, we use MAC unit. And a MAC consists of a multiplier and a special register called an accumulator. Accumulator is the addition of and multiplication are two different operations. And they are performed in parallel way. And the multiplier is computing the product accumulator and the product of the previous multiplications. In proposed architecture, we take a multiplier and adder and to accumulate the input arithmetic operations, and then we got the final output. Like for example, we take an input product and it accumulated n-1 multiplications. It can overlap n-1 additions. That is proposed architecture. And I have over to Sandhya.
When coming to advantages, low power consumption, it consumes low power, and operations, while doing the operation it consumes a high power and consumes a limited battery. The battery level is limited. And applications, wireless communications, audio processing, video processing and industrial control. It uses in audio, video and industrial control.
This is all about our project. Thank you.